We're looking at lesson 66, dealing with signs of fractions, and then we're going to look at 30, 60, 90 triangles. They're new. So hopefully you'll understand signs of fractions and 30, 60, 90 triangles. So we're going to start off by trying to add two fractions. We'll fix it. So how do we add fractions? Get a common denominator. What would our common denominator be? Our common denominator is going to be just x minus 3. Do you see how the x minus 3 and the negative x plus 3 are very similar to each other? Where we're going to find that negative 1 is right there. Negative 1/2 is the same thing as 1 over negative 2, right? So I'm going to make this plus 7a over negative x plus 3. I just put that negative in the denominator. We haven't changed the value of our expression. We just pulled the negative to our denominator. So it's going to be 7a over what? Distribute your negative to get x minus 3. Now what do you notice? The exact same denominator, right? So our common denominator is just x minus 3. What would our numerator be? And so that would be your answer. Do y'all see how that works? Okay, let's look at another example. I've got different denominators, right? But are they similar to each other? So which one do you want to be your common denominator? X minus 3 or 3 minus x? Okay, x minus 3. So how would we make that 3 minus x into an x minus 3? Okay, but are those equal? No. So what do I need to do? Multiply the top by negative 1. Because that's the same, right? 1/2 equals negative 1 over negative 2. Because the negatives cancel out. What's negative 1 over negative 1? 1. So have we really changed the value here? No, we're just going to change all the signs basically. So the first fraction stays the same. What happens to our second fraction? Negative 2x plus 3 over negative 3 plus x. But what is negative 3 plus x? X minus 3. You'll see how that works? So what would our common denominator be? So I'd have 4x plus 5 plus a negative 2x plus 3. So Jonah says I have like terms. 2x plus 8. And that's as far as you can go. Do y'all see how those work? Okay. You definitely want to copy this down into your notes. This is a 30, 60, 90 triangle. Why do you think it is called a 30, 60, 90 triangle? Those are the angles. You have a 30-degree angle, a 60-degree angle, and a 90-degree angle. 30, 60, 90. You're not going to use sine and cosine for these. Or tangent. All 30, 60, 90 triangles are similar to each other because they all have the same measure of the angles. So all of the sides are proportional to each other. If you have similar triangles, you make up proportions, right? You remember dealing with those before? They would give you one triangle here, and then they give you another one that was smaller. They'd say they're similar, and you would say, you know, this side, x over a equals 1 over 2, and you'd have to solve for your variables. You remember doing that? Okay? So you're going to want to know where the 1, the square root of 3, and the 2 go, because they're never going to change. They're always going to stay in the same position. The 2 is always the hypotenuse. 1 is the smallest side. It is always across from the smallest angle. And then square root of 3 is next to the 30 degrees. The 30 and the 3 are next to each other. Okay? Using Pythagorean theorem. What is our A? What is our B? What is our C? What is 1 squared? What is the square root of 3 squared? What is 2 squared? Does 4 equal 4? And that should hold true. So that'll help you kind of figure out if they're in the right spot, but you could still have your 1 and square root of 3 backwards. The square root of 3 and the 30 always go next to each other. So let's look at an example. We want to use similar triangles to find the values for x and y. Yeah, you can fill in the 30. So how are we going to do this one? Using a proportion. But I only have one triangle. Okay? We're going to make up our triangle. You always have to remember it. So my 60 is down here, and my 30 is up here. What goes right here? What goes here? And what goes here? All right. So, what proportion could you set up? 5 over 2. Y over 1. And x over the square root of 3. Do y'all see how that works? So, do y'all want to solve for x or y first? Okay? 2y equals 5. So what does y equal? Alright. Any questions on finding y? What about x? 2x equals 5 square roots of 3. So what would x equal? 5 square roots of 3 divided by 2. That's how you want to leave your answer. If you had used sine, cosine, or tangent to find these, you would have gotten a decimal. for that, and it would be marked wrong. You need to practice using your proportions. Okay? Any questions so far? All right. So, see if you can do this practice problem by yourself. All right, who wants to go write their answer? Okay. Either one. You can work it out. Do I need to go over that one? Okay. So see if you can try this one by yourself. I mean, some people have trouble with these. All right, so Anna and Bianca back there figured out that there are two ways to write this answer. So I want both of you to come write your answer. Are they both right? So let's say that the answer key had given us this one on the left. How would I know if mine on the right was correct? Swap all your signs. Negative, negative, positive, positive. Y'all see how that works? So if you gave me this one, it's good, just like that one's good. Usually the answer key is going to give you ones like this, though, not where they're both negative, but it's still okay. Any questions on the difference between the two answers? Did you get one of the two? Okay. So we got another practice problem dealing with triangles. You can do this one. If you want to chain toss it, that's fine. I'll go over it in just a second. Okay, I want to make sure you all have the right proportions. It doesn't matter if they're flipped, as long as they're all three flipped. And they can be in a different order. Does that make sense? Okay, do y'all want to do A or B first? B? Okay. So you would have the square root of square root of 3b equals 14. So b would equal 14 over the square root of 3. But we can't leave radicals in our denominator. So what is it called? What are we going to do? The square root of square root. But what's it called? It starts with an R. Rationalize. Okay. The denominator. Rationalize your denominator. So, what would our b actually equal? 14 square root of 3 over 3. Okay. So that's your b. Now we're going to find what? So a would equal you got to rationalize it as well. Okay? Okay? Do y'all see how this works? Any questions on this figure? Okay? So, what is your homework? Of what lesson? When is it due? Alright, so there are 5 of you. No, you don't have to. All right, each of you has to fill in one triangle.
I want the one in the middle. I want the first. I want it. I want the one. Don't give me the normal one. I don't know the
So it doesn't matter who does which one. You all have to do one. So Jonah's first. Wait. Jonah's first.
Can we just like make links?
Yeah, you got to fill it in with the information.
Girl, you can't pick up from there.
right.
Put it down.
Blue.
Yeah, I was going to show you.
Girl. Yeah, I don't know what I want.
No, what goes there?
Oh, so you should like.
Yes. That's right. Good. All right. That one was right. Who's doing the next one? Mackenzie?
Here, girl. You go, girl. Oh,
Is she right?
you did it.
Okay. Okay.
I want it now. Stop playing. Wait, give me a second to think this through. I knew I wanted that one. Wait.
Another good video.
I'm thinking. Shush. Oh! Wait,
Is that right?
yes.
All right. Anna, go for it. Is she right?
Yes.
Okay. Bianca? Is she right?
Yes.
All right, good job. You will have to know those.